Afternoon, everyone. So I am Ching Si, your host for today. Uh, we have with us Dr. Dicky Susanto, who will be sharing with us on how how can we use resources, particularly for primary maths. So I'll just give you a little introduction before we begin. I'll be sharing my screen right now. Okay, so today's session is actually on greater depth to help learners excel. So I believe most of you who are here today have actually used or will be using the Excel in Mathematics by Oxford University Press in your classroom today. So we have with us Dr. Dicky Susanto, who will be helping us to review and see how we can use these resources more effectively for you to teach in your classroom, whether on online or face-to-face, but I believe in the current situation, it has to be online. So before we begin, just to let you know that there will be an e-certificate that will be issued to your email, which you have used to register for this webinar, and it will be issued to you within 3 working days. The current session is actually being recorded, so just to let you know. And you will see at the bottom of your webinar, there are actually there are 3 functions here. So there are Q&A function where you can actually click on it and post all your questions in there, and we will be able to answer them as we go along. Along the way, you will also notice that we will be launching some questions for you to answer. So please take some time to just fill in the answers. It's a very easy poll questions that Dr. Dicky has prepared. If you have some thoughts that you would like to put in, please feel free to put in the chat function. So any opinions or any thoughts that you have, just feel free to put that in. So yes, it's going to be very exciting today. So we have next, I'm going to introduce Dr. Dicky. I believe those of you who have joined us in November last year in Jakarta, we were in Indonesia, in Jakarta, Bali, and Surabaya. So if you've been with us, you would probably have heard Dr. Dicky present on some of the topics. So just a little introduction on who we have with us today. He's actually the head of curriculum and instructional design at Kelvin Institute of Technology, where he develops and delivers pedagogical workshops and peer teaching review. So he has been working very closely with the ministry as well in designing mathematics curriculum that are aligned to both national and international standards. So in fact, I was having a discussion with Dr. Dicky yesterday, and he was sharing how he's being involved right now with the ministry in discussion on what are some of the syllabuses that they want to cover during this trying times. So I will now pass the time to Dr. Dicky, who will be able to share a lot more today. So I'll pass the time to you, Dr. Dicky.
All right, thank you, Jingse. Thank you very much for, especially Oxford, for having me here in this webinar. So I guess this is the first time been delivering a webinar with Oxford. So I've done webinars, like smaller webinars, but this is probably the bigger one. So thank you for having me here. So before we start, I would like to have just a quick poll. So first of all, so do I do that or do you do that, Jingse?
I can do that. So the first question, which language?
First question. So I just want to get a sense, like, if you would prefer, yeah.
So I've launched it. Well, I think it's actually 3 questions concurrent.
Okay, that's okay. I think everyone can answer all 3 questions. So the first question, what do you prefer, like the language? Do you prefer this to be delivered in English, Indonesian, or you're okay with either one? Or you prefer a mix of both? Or other? Like if you answer other, it means that this is probably not the correct webinar for you. I put that as a joke because if you choose other, then maybe you would like to consider a different speaker in Chinese or in other languages. Okay, so I do see we have, okay, 50% says English. Okay, there's one who prefer Indonesian. 7 prefer, yeah, that okay with either one. So a mix. Okay, good. No one answered other, which is good. So you're in the right webinar.
So we have
Yeah, and we have a mix. Yeah, we have
the grades are quite equal actually. Oh, we have
right,
some other as well.
right. Other, I don't know. Maybe.
Secondary levels or preschool.
Okay, and I think I see a lot of people already use the different resources, which is great.
The worksheets and activities, very good. So Dr. Dicky, just to share a little bit, so when we first had the lockdown, we were actually sharing resources with these teachers, with the teachers and students as well. So basically what we did was we actually sent out the last 2 chapters of the Excel in series where teachers are able to just pick it up and continue to have their classes online. So we did that in April, May, whereby teachers were able to download it's basically the entire book where they can download the last 2 chapters and share it with their classrooms.
Okay, I think that's all. Are there any?
So end the poll and I'll share the results with everyone.
Okay,
Yep.
poll.
So share results.
All right, so I think it seems majority is okay with English. So I apologize for one person who prefer Indonesian. So I'll try to speak slower and mix a little bit, but I think we are sort of in an agreement that English would be the medium for today's webinar. Okay, and then the grade level, yeah, it's quite a mix with probably majority is in grade 1. I think a lot of you already, as Jingsen mentioned about, already start using the different resources. Okay, that's great. All right, so let me just share my screen first. Share. Oh, I have to. Okay. Okay, so I know this is not a very best time for webinars. You just had your lunch, and also probably a lot of y'all have taught the whole morning. So this is going to be a tough session. So I'll try to make it more interactive. So rather than for me speaking all the time. So I hope that you will participate with all these different technologies that we have. So as mentioned, the title of the webinar is Greater Depth to Help Learners Excel in Mathematics. So here are the learning outcomes that I hope that we will achieve by the end of the webinar. So first, hopefully you'll be able to explain the paradigm shift in education. And then the second will be looking at the different resources available from OPM, which some of you are already very familiar, but we're gonna just go through what are the available resources. But particularly, we'll be talking about the third one is I'm going to pick a topic on fraction because I think that's the most challenging topic for primary level. So using that topic as a springboard, we're going to look at how you will be using the different resources, especially to help students to attain greater depth of understanding. So he's an advanced organizer. So there are 3 parts to the webinar today. We're going to look at the paradigm shift, and then explore the resources and try to unpack fractions concepts. All right, just to get started, before we get into, I would like to ask participation from you. So when you are planning your lesson, okay, so if you can go to https Padlet or just padlet.com/ my name, Dicky Susanto /OUP. and try to answer this prompt. So when you're planning for your lesson, let's say you're teaching tomorrow or the day after tomorrow, how much of the time, like the majority of the time, is spent on thinking about? So if you can complete that sentence, that would be very much appreciated. So again, it's padlet.com/Dicky Susanto, my name, and then /OUP. Okay, let me move to the other screen. So this is the challenge, like moving back and forward with technology. Okay, so if you didn't catch so it's here, Padlet.com, Dicky Susanto /OUP. So that is the address. So for participants, if you're using your phone, I would recommend if you can use your laptop instead, because it will be quite challenging for you to use your phone and switch between applications. Okay, so I can see now there's one person in there typing. You can keep anonymous, or you can also type your name if you'd like, but feel free if you want to keep it anonymous, it's okay. So please complete this sentence. When I plan my lesson, the majority of the time is spent on thinking about. So what do you think most about? You spend most time thinking about during your lesson preparation. Okay, so we have one. Okay, designing lesson plan and the right activities. Okay, so the time is spent mostly thinking about, okay, what kind of activities? Okay, what kind of right activities for your students? Okay, good. Okay, so another person typed in choosing a suitable and most effective teaching methods for students. Great. And okay, someone else wrote, find a nice games. All right, so looking for nice games, cool math games to engage the students. And particularly, it's important during this time where you can't really see the students, they're at home. So you want to engage them as much as possible. Okay, so other answered availability of online materials. So most of the time you'll be searching online. Okay, what are the available materials that you can use? Good. Okay, delivery. Some of them are overlapping, so I'm going to just move it so I can see. So exploration, okay, so another teacher says that the time is spent on finding explorations, okay, so you want the students to be active rather than just passively reading stuff. They are exploring mathematical ideas. Great. Delivery of lessons, interactive activities, media, material, method to teach students. Okay, I think these are great answers. And to connect, okay, so I'll connect the materials. Yeah, there's a lag time, so I'm still waiting for the letters to show up. Engage with students, okay. Okay, especially in this distance education. So there's one that's who mentioned about design material for online, teaching online. Yes, that's another challenge. Okay, so I'm gonna keep this open. So feel free, those of you who are still logging in and trying to type up your answer. I appreciate that. So I hope the engagement will keep you with me this afternoon. All right, so I'm gonna move back to my slide. So the first thing that, as I mentioned earlier, I'll be discussing is paradigm shift. Okay, so especially I think a lot of us as teachers in this online teaching environment, we are forced to really rethink what we do as teachers. I think as especially it becomes also an opportunity for us to reassess, to reinvent ourselves. I think this 3 months, teachers have learned more technology that compared to probably or before that your entire life. So you're sort of forced to learn all these different tools that's available. You need to rethink how you teach and so on. So one of the biggest challenges that we have, and right now it's especially during the era of this online learning, we really need to shift our paradigm, a change a way of how we think, how we do, especially in our teaching. So let's look at this cartoon. So some of you probably have seen this. I've shared it in several occasions. So here's a conversation between two boys. And then the first boy said, I taught Stripe, the name of the dog, how to whistle, right? And then the other boy said, oh, but I don't hear him whistling. So the other boy answered, well, I said I taught him. I didn't say he learned it, right? So this is a very funny cartoon telling us that, well, a lot of times our focus as teachers, we teach, right? That's our job. But when we focus on the teachings, a lot of times we don't realize that our students, are they really learning or not? So there is a quote by Madeline Hunter. She said that she's one who created this lesson plan template for direct instruction. So if you can search like Madeline Hunter lesson plan template, you'll see a lot of that shows up. But one of the quotes that she said is, teaching is not telling and learning is not having been told. Okay, which is true what we have seen in the cartoon. So a lot of times, if teaching is just telling, that makes our life as teacher easier, right? But unfortunately, that's not the case, as we have probably seen a lot of times in our classes, and especially true in the online setting. We cannot just move our PowerPoints or whatever teaching materials we have online and then expect students to learn. It's not simple as that. But we need to really rethink what it means. So here's some of the shift, especially from the traditional teaching framework to the 21st century teaching. And I want to especially highlight those yellow, there are 3 parts that I want to highlight, but definitely what teachers should do to what the entire system should do. So no longer we are looking at it as an individual effort, but as a system. The education system itself, the school and so on, is an effort that is shifting, that is something that the entire system is a systemic effort in order to promote changes in education. But definitely there is a more emphasis on the student focus rather than teacher focus. So I really appreciate that some of you, when earlier you mentioned about you want to find materials that's engaging for your students. So I can definitely see from your answer, your focus is more on your students rather than on the teachers. Okay, if I were to ask the same questions like 10 years ago, probably a lot of teachers would say, oh, I'll be spending my time thinking about what I'm going to do in my class, right? What I'm going to prepare, what are the PowerPoints. So the focus is more on the teaching or the teacher rather than on the students. So from your answers, I'm glad that a lot of you start to see the importance of trying to engage the students, what the students are interested, motivated. Okay, so that's definitely a shift in our mindset in terms of teaching. And also the third one is the teachers deliver instruction from that framework to now it's more for us to facilitate learning. And this becomes even true in the context of online learning. It's very difficult and challenging for us to know what the students are doing in front of their computers at home. But what we can do is we can facilitate their learning by providing the materials and by really engineering, I would like to use that word, engineering the kind of learning that's going on in each of their home. And then the fourth, fifth, sixth, I'm going to just skip. You can just go through, but this I talk about the vision, how it's changed, defining vision, and also about structures. And I want to go to the last part is the focus. The shift is from the focus on teaching, but rather to now is the focus on learning. So we can see that more and more we are shifting into what the students are doing, what the students are thinking, and how they are learning rather than the teaching itself. Okay, so from there, I like to address. So a lot of your answers when I asked you what you were really focusing on, which is great, focusing on students, but I don't really see one particular aspect which is missing, which is the thinking, the learning. So when we want to create a greater depth of learning, one of the things that we need to start to do is rather than thinking of, okay, what am I going to deliver? What's the materials that I want to share with the students? And what are the kind of activities that I want the students to be doing? One of the biggest questions that I think we need to answer is what are the students thinking, or what should be the students thinking when they are engaging with all these activities, with all this learning. Okay, so rather than just thinking only about the activities, about all the games, which is great, you can use all these different games. If I'm going to share also some of the PowerPoints that you already have access to. Those are all great materials, but what we need to go one step further is thinking, okay, how are my students interacting with these materials? What are the things that they should be thinking when they are looking at, reading, okay, engaging in those materials? So when you design all those, I think what you want to really think about, what are the things that they should not be thinking, okay, or sometimes we call it misconceptions, and what are the things that you want them to be thinking? So given that, I would like to switch a little bit to the second part, which is looking at the resources. So earlier during the poll, you already have answered which of the materials are available. So I just want to go through, but also talk about what you can do with the materials. So for the scheme of work, I'm sure a lot of you already see it gives you a big picture of what you need to teach the entire year. Okay, and soon I think the Ministry of Education will publish their new policy or sort of like a simplified version of the competencies. So instead of having to teach like 12 different days, I think it has been cut down to almost half some of it. So that gives you more time to focus on the important things. Okay, so I think soon, like end of this week or next week, on the end of the month, it will be published. So that's sort of a good news. So it means that you don't have to cover everything, but having this scheme of work really helps you to think about what are the ideas. But okay, I want you to focus not only on what is being taught at your level. Okay, since now it's available for you. So let's say this is taken from the third grade. Instead of just looking at the third grade, I think it's also good for you to look at other grade levels. So for example, if I show you here on the screen, this is equivalent fractions, 3 and 16, recognize equivalence between 1/2, 2/4, 4/8, and 5/10 using diagrams. Okay, so it's also good to think about, okay, what did the students learn the year before and what will they learn the year after. Gives you a bigger picture and particularly helps you to think about what are the things that students should already learn and where will be they going next after this. So that gives you a bigger picture when you start to think and design your lesson. So for instance, here in third grade, when they're learning about equivalent fraction, notice that they are only focusing on the denominators are multiples of 2. Okay, so that's a big thing, okay? So it means that when you're teaching third grade, you're not going to get into all this different kind of equivalence fractions, but you want to focus on this. And why is that? Well, because this is the first time that they really are looking at it more formal. Okay, how do we know that? Okay, that's where you go into the last years, right? This is the second grade. In second grade, they have not really looked into the idea of equivalence. What they do is they learn about the parts of a group. Okay, they do learn about doubling and halving. That sort of serve as a basic for them because they know that when they doubles and they halve, okay, the amount is a multiple, so that becomes a basis for them to understand what comes next. So that means that as a teacher, this gives you an information that, well, you don't want to get into really quick, especially a lot of teachers are tempted when they teach this equivalent fractions. Okay, all you have to do is you have 1/2, you multiply the 1, and then you multiply by 2 by the same number, and then you're done. Okay, that doesn't work because that is very algorithm. I'm gonna talk a little bit about that later, but so when you're looking at the scheme of work, I think this is a good idea to really go in deeper into it, trying to see where the students are coming from and where they are going to give you what scope that you need to focus on. Okay, and you don't want to get into right away into the algorithm that is multiplying the numerator and denominator by the same number, because here you can see that it particularly focuses on using diagrams. And why is that important? Because it's still building understanding the meaning of equivalent fractions. So you don't want to get right into multiplying the algorithm. Okay, so that's going to happen in the next year in grade 4 when they start recognize the equivalence between 1/4, 4/8, 5/10, 1/4, 2/8, 1/5, 2/10. Okay, and then understand the equivalence. So that's where they start to get into more formal idea using not just the diagram. So no longer they rely on the diagram, but they get into more of the algorithm. Okay, so this is one way you can use the scheme of work where you look at what are the available resources, okay, where you can find them, but particularly I think it's good as teachers we have a broader picture because math is something that keeps building, okay? Even though you're teaching third grade, please don't just know, okay, I just need to know third grade, that's it. I don't need to know what happens before, what happens after. So it's good to know what's happened as a trajectory of what the students' journey of learning in the mathematical concept. So there are the fractions cards here from the Black Line Masters. You can make copies and give it to your students at home. They can cut it and make it into cards. There's fraction strips. There are worksheets where you can use with your students. And I don't see a lot of teachers mention about using the challenge questions. So that's another feature I think is very important, okay? Especially some of you are thinking, okay, how may I teach this? So you don't have to wait until the end to give challenge questions, okay? So there's another way of teaching math, which is called, you call it a problem-based learning, okay? So you start with a problem at the beginning of the lesson rather than at the end. And from this questions, when they're trying to solve this problem using whatever method that they can think of, then you start getting into the ideas or the concepts. Okay, so there's another way you can teach math rather than teaching them the concept first and then showing them examples. and then assigning them problems. And finally, the last part is where they have the challenging problems. You can actually flip it around. Okay, you start with the challenging problems. They may or may not be able to solve it at the beginning. It's okay. They struggle with it for a bit, maybe, but that actually gives them something to really think about, and then they try to use whatever they have learned before, try to build that understanding into the new ideas. So that's another way you can actually use these resources, challenging questions, rather than just assigning at the end. Okay. And how many have you used glossary? So maybe this is one piece that's sort of set aside, okay, other than, okay, this is good to know, and there is the translation, right, the English and Indonesian. Okay, so I think this is a nice example where students, because learning math is also learning a new language. So a lot of the terms are important, especially when we think about equivalent fractions. So for example, 1/2 and 2/4 are equivalent fraction. But here is different from saying 1/2 and 2/4, they are the same. Okay, so a lot of times we need to be very careful with our language. So as you can read here, okay, the equivalent fraction shows that they are equivalent. They are not the same. We don't say 1/2 is the same as 2/4, because that will confuse students a lot. So a lot of times in this glossary, it gives you more precise language, and also give students also a better understanding. So allowing them to look at this, to read this. And a lot of times I see teachers, they will post this at the beginning before they start the unit, okay, so that the students have access, they understand, okay, what are the vocabulary they need to be using. And that's something also important in learning math, okay? Learning math is not just learning about numbers, about symbols, but particularly about the terminologies, okay? Being able to use precise terminologies is important. So back to this example, if you sometimes if you're not careful, I do hear sometimes teacher will say, oh, they are the same, 1/2 and 2/4, they're the same. But at other times they will say, oh, they're not different, they're different fractions. 1/2 is 1 and 2, and numerator is 1, denominator is 2. But 2/4 is numerator 2, denominator 4. They are different fractions, but at other times they are the same. So that really confused students. So you want to use very precise terminology. They are not the same in terms of the value, but they're not the same in terms of how they look like, but they are equivalent in they have the same value. So that's important. So I think the resources here are available to help you really shape not only the mathematical ideas, but also the language, being more precise, especially if your students have to work with 2 different languages, that becomes more challenging, right? So having this available for them is important. All right, so that's the second part of today's session. So I've gone through some of the resources. Feel free if you have any questions about how to use. But I think I will focus on the third part on how to use PowerPoints, especially. So that's probably majority. I think the teachers use that especially for the home learning. So you would present that to your students. But before we start, I would like just to conduct a quick Kahoot, okay, to just review some of the basics of the concepts in fractions. Okay, so let me just move my screen first to Kahoot. Okay, I'm sure by now a lot of you are already familiar with Kahoot. Okay, still loading. Okay. So go to kahoot.it and enter your game pin is 69497. Okay, I'm gonna take the volume a little bit. Yeah, I choose a little bit more upbeat music so that no one falls asleep, right? Okay, we have one player in. Still waiting for. So while waiting for other players to join in, you can move a little bit around to the music, right, to get your blood flowing, especially after sitting for quite some time. Maybe do a little bit stretch. Yeah, probably a lot of you found that teaching online, you sit for a very long period of time. So it doesn't really do good to your body. So move around a little bit, stretch is fine. Okay, we have 13 players. Still waiting for quite. So how many participants do we have?
It says I'm in.
Oh, okay, you're in as well.
Yep.
Okay, we have I think 52, so 16. We're still waiting for others. Okay, I'm gonna wait another minute before it gets started. So I've prepared some really conceptual questions about fractions just to get a sense. So this is all anonymous, so you don't have to worry if you answer incorrectly. But just to get a sense of what are, like, why is fractions so challenging, and so before we get into discussing more about how we can teach fractions better. Okay, I'm gonna just get going. So for others who are still trying to join in, feel free to jump in anytime. So I'm gonna get started with a question. Okay, get ready. So the first question, which of the following is true about, so rational numbers are the same as fractions. All fractions are rational numbers. Some fractions are rational numbers, or fractions are irrational numbers. Okay, wow, okay, so we see quite a spread of answers. Okay, some answers, the first one, so majority answers actually the second one, all fractions are rational number. So a few answers, some fractions are rational numbers, and also same number answered irrational numbers. So we can see that I think a lot of us are still sort of confused what rational numbers are. So just to get a quick sense, rational numbers are numbers that you can express as fractions, a over b, okay? But rational numbers, those are integers, right? A and b's are only integers. So you cannot have, say, square root of 5 over 2. So that is not considered to be rational because square root of 5 itself is irrational, but it is still a fraction, okay? So a fraction, some fractions are rational numbers. So it's got some part of it where both the numerator and denominator are integers, so those are considered to be rational numbers. Okay, so I hope that clarifies that understanding of what fractions are. Okay, let's go to the next question. Okay, we have shining, rocky hamster in the first place and smooth raven follow up. Okay, let's go to the second question. The idea that a fraction 3/4 is a single number is conveyed through a point on the number line 3/4 away to the right of 0, 3 parts shaded out of 4 parts, 3 is the numerator and 4 is the denominator, and 3 copies of 1/4. Okay. All right. So only 2 persons, 2 teachers got it correct. So although it is correct that 3/4 is 3 parts of 4 parts, but that doesn't show us that 3/4 is a single number. Okay. If you ask students, a lot of them, they don't see 3/4 as a number. They see 3/4 as 2 numbers. There's a 3, there's a 4. The 3 is shaded, 4 is the number of parts. Okay. But what we need to get students to see is actually 3/4 is a number. Okay. And how do we do that? It's shown on the number line, because a point on the number line shows that it is a number, it's a single number, it's not 2 different numbers. Okay. So although 3 is the numerator, 4 is the denominator, but that kind of understanding only makes students think that those are two different numbers, put them together. So what is important for us as teachers is we want to make sure that our students see fractions as numbers, not 2 different numbers, but as single numbers. And how do we do that? Okay, the number line is a very good model, a good representation on how we can show them it is actually a number on the number line. Okay, all right, let's see. Rocky hamster still rocking in the first place, followed by cute boa. Okay, let's go to the third question. Is it true or false in fraction the parts need to be equal? Ya, jadi dalam pecahan bagiannya harus sama. Ya, the parts needs to be equal. Okay, so a lot of you answered correct. 14. Yes, they have to be equal. Okay, if it is not equal parts, then you cannot call it a fraction, because all parts should be equal. Okay, what does it mean to be equal? Equal means that all the different parts have to be. We'll talk about that more in the next questions, but we'll just for now accept it has to be equal. We'll talk about other. Some of you who answered false may be thinking about something else. Okay, you're not wrong, but you might be thinking something different. Okay, we'll talk about that after several questions. Okay, still hanging, so some are trying to catch up. So a fraction is smaller than the whole, the unit, or 1. Is it true or false? Okay, so a fraction has to be smaller than the whole. So you have a 1 whole or a unit or 1, so the fraction is smaller. Okay. Oh, okay. This divides equally interesting. All right. So this is another big misconceptions that students also have, which is thinking that, well, you have 1 whole. It means that the fraction has to be smaller than that. So it's 3/4, 2/3, 1/2, and so on. Okay. But don't forget that fractions also can be bigger if you have multiple wholes. Okay. And also if it is, let's say if you have a mixed number or an improper fractions, So you can see that those are actually, the size is bigger than the whole, right? So it's not always that the fraction has to be smaller than the whole. Okay, I think Daring Bunny is taking over the first place. All right, let's go to the next question. In fraction, the parts must be clearly delineated, clear lines dividing into equal parts. Okay, so 18 says true. Okay, which is actually incorrect, only 4. To show you why, I need to use a different, okay, all right. Let me show you what it means, okay? So let's say if I have this square, pardon my drawing, trying to draw online is not as easy. Oops. Okay. So if I ask you what part is a shaded part, what can you tell me? So in the previous question, it means that, well, we cannot say it because it's the lines are not all there. Okay, there's a missing line here. But can we still identify what fraction is that part? Well, yes. The answer is still yes. It is still 1/4, even though I don't have that line clearly drawn to show the fourth. So we don't see the fourth there. Students might even say, oh, there are only 3 parts, right? There are 3 parts, but they're not equal parts. Okay, but it still is a fraction, which is 1/4. All we need to do is just extend the line here. Okay, but that shows another big misconception that students have. They think that only when all the parts, okay, are clear, they know all the different equal parts, then they can find the fraction. Otherwise, they cannot. So that's a huge misconception that we as teachers need to address as well. Okay, let me go back to Kahoot. Okay. Okay, Daring Bunny is still in the first place. Let's see, 2 more questions. 6th one, in fraction, the parts must have the same shape. Oh, wow. Another evenly split. Okay, 10 and 10. Okay, so this is interesting. Yeah. So this is another thing that students might also have a wrong idea that the shape has to be the same. Okay, let me show you an example here. Let's go back to this. Okay, so let's say, okay, so, oops. So what fraction is that? Well, the shapes are different, right? We have squares here, we have squares, we have triangle, but we can still see that this is 1/4. So an important idea in fraction is that they should not focus on the shape. It's not about the shape, it's about the size. Okay, that's why earlier in the previous question, when we talk about fractions, the parts have to be the same. Now it has to be the same size. Okay, doesn't have to be the same shape. So this is where a lot of students are also struggling when they get into later on, right? When they see that the shapes are all this different, doesn't have to be necessarily the same, and they fail to see those are equal parts. Okay, so as teachers, when you're designing your lesson, you want to be thinking about, okay, what are some of the ideas here, misconceptions that students might have that we want them to avoid. And this is actually another big misconceptions that students have when they are thinking about fraction, that the size, okay, they're thinking about the shape instead of the size, right? We are talking about the area. These are all the area models. So when we talk about the area, it's how much space, the size of the shape that matters. Okay, let's see how. Oh, Cute Boa has taken over first rank. All right, let's go to the last question. Still have opportunity to take over. So in fraction, the shaded regions, oh, so we have two more questions. The shaded regions must be grouped into one part. Okay, right, there's a significant improvement. So a lot of you said that they don't have to be grouped into equal part, right? So sometimes the shapes can be, the shaded part can be spread over, right? It doesn't have to be all clumped together. Good. So I don't think I need to explain for this. All right, last one, last question. In fraction, the whole is made up of one piece. Is it true or false? Okay, wow, evenly split. All right. Okay, so again, remember, although typically, normally, we would see fractions to have one piece, right? Let's say a one circle or a one rectangle as your whole, but that's not necessary in terms of it has to be only one. Sometimes you can have multiple holes, okay? So let me show you using, okay? So an example is, let's say you have two pizza, right? And you want to share with, let's say, three people. So what do you do? Well, normally then you would cut this. Oops. Yeah, you would cut this into thirds, cut this into thirds, and then split it. This is 1, 2, 3. You share it with 1, 2, 3. So each person each get 1/3 and 1/3, which is 2/3. So the question is it 2/3 of one pizza or 2/3 of two pizzas? That's quite challenging, right? So sometimes people think it's 2/3 of two pizzas or 2/3 of one pizza, right? But in this case, we can see that we are talking about this two pizzas as your whole rather than one pizza as your whole. Okay, so your 2/3 is talking about 2/3 of one pizza, not 2/3 of two pizzas. Okay, because if you have 2/3 of two pizzas, you end up with 4/3. Okay, so that becomes more complex, right? When you think about the fractions, if you think about this as you have the multiple wholes, but we're not talking about the one whole as your only one, right? Another example is the SAT model. Okay, so let's say you have 8 chocolates, right? 8 chocolates or candies, right? And then you, oops, okay, and then you share this one, this one, this one with your friend. So how much of a candy have you shared with your friend? Well, you would say 3/8, right? But 3/8 of what? 3/8 of a set, not 3/8 of one candy. So your whole is not this one, but your whole is this entire. Okay. So be careful when we are teaching fractions. The whole itself can be a one whole. It can be multiple wholes, and it can be a set model where you have all these different discrete parts. So it's not continuous, like the pizza example is a continuous model. This is a discrete model. Okay. Well, so you can see from all these questions that that's very conceptual of what fractions should look like, and it's quite challenging. Okay, so let's see who's our winner. Oh, okay, our winner is Diligent Sloth. Okay, give yourself an applause. Followed by Daring Bunny. Yeah, so as you can see from this example, okay, let me just turn this off first. Okay. Yeah, so I hope that I have made a case to you that there are a lot of misconceptions going on when students are learning about fractions. And you can see why. So it's important for us to really think about, okay, learning and teaching math is not just about presenting information, but it is something that you want students to really think about it. And as you create these lessons for our students, there are something that you want to really focus on in terms of the thinking. So just go through a little bit some of the challenges, okay, in fractions. So fractions plays a key role in students' feeling about mathematics. A lot of times when students start learning fraction, that's where they become frustrated, okay, and they give up. Before that, probably they like math, they enjoy math, but once they get into the fractions, a lot of them becomes not very happy about math. They don't like math anymore. Okay, so fractions are fundamental to school math and daily life. It's very important. In everyday life, also, we use a lot of fractions uh, as we go shopping and all and cooking. So those are all fractional values. And also fractions are foundational to success in algebra. Now, why is fractions very challenging? Okay, there are two particular reasons why, because there's a shift in their cognition, in their thinking. Okay, before fractions, everything is additive thinking. You're adding to it. How many more? How many less? When you compare additively by addition or subtraction. But when you go to fraction, now it's shift into multiplicative thinking. Okay, I'm going to talk a little bit more about that in the next slide. But the second also shift that happens when you're learning a fraction, you moving from this whole world of whole numbers into a different world of numbers, which is the rational numbers. So no longer you're dealing with just these discrete numbers, 1, 2, 3, 4, but now there's fractional values. So let me show you an example of additive thinking. So let's think about this. Two bamboo trees, right? Let's say the A bamboo tree's height is 2 meters, and then B is 6 meters. So let's say after a year, A has grown into 8 meters, and B has grown to 12 meters. So if I ask you the question, which bamboo grew more? How would you answer it? Okay, I'm gonna just let you think about it. If you want to respond in the chat box, that would be great. Okay, are there any? Okay, so one participant answered A. A grew more. Why? What's the reason? Oh, 4 times. Okay, B is 2 times. Good. Yeah. But let's say if you were students, which one do you think will they? What will their answer be? So I think most will say A. But if this is given to a students, most likely their answer will be the same. Why? Because they would say that, well, okay, from 2 to 8, there is a change of 6. From 6 to 12, there's also a change of 6. Okay. So for them, they are thinking more in an additive thinking mode. Okay. And this is where we are talking about absolute growth. The absolute growth are the same. Both the bamboo grew 6 meters within that year. So a lot of you are answering A because you're thinking more in terms of a relative growth. That is growth based on what their previous height was. So the tree's previous height was and how much it grew. So that's multiplicative. Okay. So you can see that there are these two different kinds of thinking. And students, when they were in the earlier grades, they were thinking additively, and then suddenly now you want them to think in a different mode. So that becomes a very challenging task for them to see the same idea can be thought of with two different kinds of thinking, additive thinking and multiplicative thinking. So you can see how you cannot just expect them to suddenly, you teach them, okay, this idea about fractions, about multiplication, and then they will automatically shift from that, from a additive to a thinking, multiplicative thinking. So it's a slow process, and it needs a lot of teachers' guide and instruction to make sure that they see the difference in these two. Okay, another example, if you were to compare 13, 15, and 16, 14, 16, a lot of students will say that, well, they are pretty much the same, right? Because both have, in both cases, the denominator and numerator differ by 2. Or some of them will say, well, I add the same number 2 to the top number to get to the bottom number. So they are the same. So what is missing here is, again, they don't think about it multiplicatively, but additively. And one of the biggest challenges when, especially when we are talking about the equivalent fractions, there are actually double multiplicative nature in equivalence. Okay, so a lot of times we focus on this part, the multiply by 5. So the numerator starts with 1, and then you multiply by 5. And denominator is 4, and you multiply by 5. And that's it. Not realizing there is another multiplicative relationship going on. Okay, this is called, actually, let me just move here. Oh, hang on a minute. I'll get to that later on. But to show you that the complexity here is, it's not something that we can just teach them how to do the algorithm, and then that's it, they're done. So that's why earlier, as I mentioned, do not teach them the algorithm right away. Make sure that they get a sense of what equivalence is, make sure that they really understand the meaning, and then looking into the structure of the equivalence before they then are introduced to the algorithm. And these are just some examples, again, how moving from whole number to rational numbers become challenging. So a lot of them will say that 1/4 is greater than 1/5 because 4 is greater than 3, and so on. I'm not going to discuss individual this part. So I do want to talk about, this is where, as teachers, I want to really urge you to not to rush to algorithm, not to rush to the formula, not to rush to, okay, here's a quick way. Okay, because when you do that, students don't really have a good sense of what fractions are and the operations of fractions. They memorize things. They may be able to do a couple of problems well, but then they don't have a deep understanding of the fractions. And that actually will be detrimental for their continuous learning. When they get to algebra, that's where a lot of them struggles because they don't get the idea of fractions here. Okay, so now, so what can we do in terms of our teaching, and how do the resources that OPM has provided help us? Okay, so here's an example from first grade grade one fractions, when they were first introduced the idea of halves. So I hope that you notice here, if you look at the first grade, they are not even introduced to the symbol of fraction. Okay, and there's a reason why. Okay, a lot of times when teachers teach fraction, oh, okay, they see this 1/2, and then right away they want to introduce 1/2. And actually that becomes very confusing for students. They don't know why there's a 1, there's a 2. So teachers will say, okay, 1 because you take one part, and then there are just 2 parts, but still it's very confusing for them. So you can see right away from the resources itself that the way that they are created really take into consideration that aspects. So when you're showing this to a student, so again, I want you to think about, okay, what should be the students thinking about when they are looking at this? So let's say you're teaching. So what are the ideas that you want them to be thinking? Well, first of all, you probably want the students to be thinking of, okay, originally there's this one piece, and then you cut it into 2 equal parts. So the equal part has to be emphasized, right? So even though in nature, like in this situation, those 2 are not exactly the same, but you want them to get the idea because they are also used to the experience at home where they're sharing with their siblings, with their families about halves. So that's something that's built into them. They know they want it to be equal in size. So you want to build from that intuitions that they have. Okay, it's very ingrained in them that they want equal pieces when they're sharing a cookie. Okay, so what kind of thinking that you want them to be engaged in? So think of what kind of questions you want to ask them. Okay, what are the things that you want to avoid? So again, here as we talked earlier from the Kahoot and so on, that is important for them to see that, well, for now, because it's their first grade, we are not getting into, so earlier somebody commented, okay, those are great, but probably not for the earlier age. For the earlier age, we're going to stick with the same shape and same size. Okay. Later, once they get the idea that, well, the shape doesn't really matter. Okay, as long as the size, okay, whether it's the area or the volume, they are the same. It's okay. So at this point, because it's their first introduction, we're going to keep that simple for them to make sure that it's the same size that matters, and the same shape is still engaged here, so they see both of that, and then they can engage it. Okay, so what does it mean to be same? Now that's another thing that we want them to be thinking. What does it mean to be the same? So they can do all this paper folding activity. Same means, well, when they overlap. So you see first grader, when you talk, oh, they're the same. Okay, what does it mean to be the same? So you need to be more explicit. So with these activities that help them to see, okay, the same shape, so they can overlap. Okay, that covers the same space. Okay, and then with numbers, okay, another with papers, you fold it so into 4s, so 4 pieces, and then with a set model, okay, so half of. So it means that you have 6 and half of. So you can see that builds into their understanding what half means without getting into the symbol half. Okay. And definitely we can build from their daily experience of sharing equally. So let's think about this. So if you were teaching this to your first grader, like what kind of questions that you would like to ask them? What do you want them to be thinking about? Okay, first of all, the color doesn't really matter here, right? So we want to focus on what is defining attributes and non-defining. So in this case, when we're talking about fraction, well, the color doesn't really matter. So you want to emphasize on this kind of thing because children think very differently from adults. Okay, for us, we might be focusing on the numbers. They might be looking, oh, the colors. Or does it matter the color? So let's say if I move, let's say 2 green on the left, and then on the right, I move the red from the left to the right. Is it okay? Well, for the children, maybe it's problematic because they want it to be the same, right? But because we want to emphasize, it's not about the color, right? Even if I switch around the color, it's still half, right? So each person get halves of the whole set. So when we are delivering, okay, so remember, the resources are available. The resources do not teach the student. It's the teachers who needs to teach. So the resources are there as a stimulation, but you want to think about, okay, when students are looking at this, what should be they thinking? Should they be thinking about the colors? No, we don't want them to be thinking about the colors, right? We want them to be thinking about the aspect of the quantity and what half means, okay, when they're sharing equally. What does it mean to share equally? Okay, then they can probably do like distribution, right? 1, you 1, me 1, 2, 2, and so on. Okay, so that's what I want you, when you're engaging, when you're using these resources, really think about what are the things that you want your students to be thinking. Okay, I'm gonna skip this. Okay, a lot of animation, which is great. It's all done for you. You don't have to create any of this. Okay. So another example here, let's say equivalent fractions in 3rd grade. So when you're presenting this, what do you want your students to be thinking? Okay, well, first of all, you want them to be thinking about what does the shaded part represent in terms of the fractions. Okay, and then you want them to notice that some of them are further partitions, further divided, let's say A and D. Okay, they are the same, but you have more partitions, more parts. So you want them to be thinking about what equivalent fractions mean, right? So the animation does a good job moving things around. So now they can see, okay, A, C, D, E have the same. So and then B, F, G, H have the same. And then you want them to start thinking, okay, what's not there? We don't want them to then start getting this wrong idea, okay, that it has to be the same shape. So you want to start thinking, okay, how I want to engage my students to think more deeply about it rather than just, okay, superficial thinking, as long as the size is the same, the shape is the same, I'm done. But remember, okay, there's this whole misconception that they focus more on the shape rather than the size. So you want to then further ask them, okay, what about this? Are these equivalent? Why or why not? How do you know they are equivalent? So what are equivalent fractions? Can you come up with a definition? Okay. And as teachers, you want to be thinking about, okay, what kind of answers would you consider to show a good understanding of equivalent fractions? So let's say if a student say, okay, they are equal because they look the same. Well, probably that's not a very good answer. Then you want to pursue further. What do you mean by looking the same? Can you explain more? So what kind of answers would you then use as evidence of really the students have understood the idea of equivalent fractions, despite that it's not the same shape, it's a different shape? Okay, then they might say, okay, I can move that triangle up so again, the geometry is there, the motion. So they have a robust understanding that as long as I can show that the area, okay, the covered part are the same size, then they are equivalent. Right. So here's what really want you to, as you're thinking about your next lesson. Okay. It's great that you think about what activities. It's great that you want to engage your students. Think about what kind of games. But I want you to go further. One more step is think about what your students should be thinking, ought to be thinking, and how you can help them to do that. What kind of questions you can pose, what kind of additional, for example, here I added this slide here to really get them to think more deeply about the idea of equivalent fractions. Okay, So earlier, this is the wrong, should be earlier. So this is an example when once they have a good idea of what equivalent fractions, if they only do symbolically, so for example, you only teach them, okay, you multiply the numerator by the same number and denominator by the same number, then your students, I can guarantee a lot of your students will have a hard time looking for this. So here is a problem where you have to put in the two boxes, what number, so that the equation is true. So a lot of your students will start thinking, okay, well, I can't find any numbers or any whole numbers that you can multiply 6 to get to 15. So probably only a few students who really have understood it will be able to do that. But if you build their understanding, especially looking at, remember earlier I mentioned there is a between ratio, so you're looking at across, but also you're looking at the within ratio. So instead of thinking across, I can also think about, okay, 6 and 5, 15 have a common factor of 3. So if I divide 6 by 3, I get the numerator 3. I divided this by the same, 15 by 3, I get 5. So you can see the multiplicative structure in the equivalence becomes clear to them, and they should be able to solve this kind of problem easily, because now they have a good understanding rather than just a simple multiplicative structure of only the between ratios, but they're also looking at the within ratios. So these are examples that I just want to pick one idea from fractions, equivalent fractions particularly, to showcase that you should be able to do that with any kind of topics. Think about what's behind, what's the thinking that you want the students to be engaged in when they're engaging in activities, in materials, PowerPoints, anything that you have prepared for them. So I don't think we have much time, Jingse. I initially planned to have you to pick one from, I already prepared some PowerPoint slides from the resources. So I'll just share what it looks like, so that if people want to engage in the conversation, continue engaged in the conversation is okay, right? Because I will leave that open. So for example, if you go to first and second grade, so this is the PowerPoint that I have picked from the resource. So so when you're looking at this, when you're preparing your lesson with this PowerPoint, so what should your students be thinking and doing when they're looking at these resources? So for third and fourth grade, I picked this from the fourth grade, when they are looking at division of fractions. And there are two slides. So first they are looking at division of whole numbers, and they're looking at division by a fractions. So what are the thinking that should be involved when they're looking at this, when they're trying to understand how do you divide by a fractions? Okay, and then finally in the fifth and sixth grade, looking at this idea of you have 3 pizzas divided by 6 person. Okay, so what are the thinking that's involved in that? What do you want your students to be thinking? What are the things that you want them to avoid? Kind of overgeneralization. Okay, here there's 3 and 6. Okay, so which is nice. You can divide them like by halves. But what's going to happen if you have something that doesn't have a common factor? So you won't be thinking about the kind of questions, the kind of cognitive engagement that you want your students to have when they are looking at these materials, when they are reading this, when they are accessing this. Unfortunately, we don't have time, so we have only like 10 minutes. So, but feel free if you want to engage this with the Padlet. So all you need is just the same as earlier, but it's Excel. So padlet.com / my name, Dicky Susanto, / Excel. 1, 2 is for first and second grade, 3, 4 is third, fourth, and 5, 6 is for fifth and sixth grade. Okay. All right. So I think I have to stop now because should have time for a question, right?
Yeah, yes. Okay, thank you, Dr. Dicky. So we have one question that came in. So one person asked that he or she totally agree that teachers need to fix the misconception in fractions, but isn't it going to be a bit too complex for the third or fourth graders to incorporate this as their basic concept?
Right.
Would you want to answer this?
Yes, yes, absolutely. And you are correct. So what I showed you is not something that, well, immediately you would then give to students. For example, earlier I mentioned in the first grade, right? Even though the idea is later on they should realize that, okay, the shape doesn't really matter, right? But for first grader, you don't give that right away because that will be more confusing. It's too complex for them. So you start off with, okay, same shape and same size. But if you continue with that
Building on it.
only, then
Mm.
that's a problem. But you want to build. When they get in the older grades, that's where if you look at the materials, it should be more complex, and you should start giving them shapes that there are like fractions that they don't have to be exactly the same shape. Right?
Mm.
But the problem is when teachers continue to use the same models without changing, without providing more. That's where it's problematic. So I totally agree. You need. That's why earlier I mentioned when you look at the SOW, the scheme of work, make sure that you can see the progression from first grade all the way to the upper grades. There's definitely increment of complexity. Okay.
Okay, so I think there's some of you who have been asking about the resources. So what I'll do is I will be sharing the resources to just walk you through how it looks like. So I'm going to share my screen right now. Okay, so basically, what you do is you should look out for this OPM resources.oup.com. If you have a copy of our Excel in titles that you probably see here, you will be able to find the URL at the back of the book. So use this URL, you will come to this website. So basically this website has all the resources for you as teachers. So for example, if you are a primary school teacher, so these are all the titles that you have. So assuming you're a grade 3 teacher, so you will be able to see these resources. So you have the math and science. So what you will need to do is you will need to register. So in my case, I have registered. So you will see that I'm changing. So if you have not registered, so just register for the resources. You will need approval from the backend. So basically that will take approximately 3 working days for us to ensure that these resources are given to teachers. So I'll just show you an example. So this is an Excel maths. So you will be able to see that these are all the resources in Excel maths. So you have the scheme of work. So I'm sharing. So whatever Dr. Dicky has shown is actually from this website. So a lot of the materials that he has shown is from this website. So you are able to download these resources. So whether if you want to download all or you can download part of it. So there are PowerPoint presentations as well. There's some printable worksheets and activities. So if you download, I think you won't be able to see on my shared screen because it's appeared as a separate, you will see this button, the zip file. So once you open it, you will be able to see the PDF resources as well as the PowerPoint resources. So can you see my zip file right now? Dr. Dicky, are you able to see the zip file? I guess you may not be. So let me...
Not the zip file, just the download.
Okay, so what I'll do now is I'll share my zip file. I'll share... So what happened is I have opened up the zip file, and this is an example of the PowerPoint resources that you can find. So these are all available for you teachers. So if you want to conduct your classes online, for example, this will be ideal whereby you can just pick up these resources online and run it in the class. So a lot of these materials were actually shared by Dr. Dicky earlier. So these are some examples of how you can use the resources. All right. Okay, so other than that, there are some Okay, hold on, yeah. So I'm going to share another editable scheme of work. Just share. So these are the editable scheme of work. Again, it was shared by Dr. Dicky. So all these resources are actually available on the website that I shared earlier. So what you can do is go to the back of the Excel in books and go to the website. And on the website, you will be able to find a rich number of resources where you can actually download and use it with your students. So there are even the RPP, there's some challenging questions. So these are all the resources. So we have it available for math and science, all the way from primary grade 1 to grade 6. So do check it out. Yeah. So before we end, I'll just like to remind everyone that in fact, we will be having another session on online teaching. So we will be sending you an email shortly on on when exactly it is. So I think earlier we have planned it for Tuesday's session, but we have been getting a lot of feedback that some of the teachers prefer to have it on a Saturday. So we are going to finalize all that. So once we are going to send you the invitation and do remember to register. So, so thank you once again, Dr. Dicky. It has been a very insightful session. I enjoyed the Hood session, yeah, I really enjoyed the session. I have a son who is 9, so it's very interesting that you talk about how we teach fraction in our daily lives and how we can actually introduce small concepts to them before getting them giving them numbers, incorporating the big numbers and confusing them. So hold on, the slides help me to teach online without taking any picture from the book. Thank you so much. This is from Devi. Thank you. We are glad that you have used it and you find it useful. So science.
And I don't know, is that we have one person, Dina Estrada, she raised her hand, or?
Yeah, so.
She wants to ask a question, or is that okay?
I've asked her, she didn't reply. So let's, we can allow her to talk. So Dina, if you would like to talk, you would like to share something, I've actually allowed you to talk. You can actually unmute yourself and speak to us actually. So if anyone here who would like to share your thoughts before we go off, you can raise your hand. There is a button at the bottom that allows you to raise your hand. So you raise your hand, we can allow you to speak, and then you can share whatever thoughts you have with us, whether if you find this session to be useful, whether if you want more information from us. In fact, we have our colleagues, our consultant here, Dara, who is amongst the attendees, so he's around. So if you have any question, we are also be able to come back to you. So I don't think Dina will be speaking. So
Ma'am, I'm sorry, ma'am. Ma'am, I would like to ask if you provide the what do you call this, the video clips in every topic.
Video clip in which topic again? Sorry.
Okay, for example, if I'm teaching the place value, there is a video clips on it.
Okay, so you mean the YouTube video resources in the scheme of work?
Yes, sir. Yes, sir.
So that's actually openly available. You can just copy that link and then just look for the YouTube video.
Okay, sir. Yes. I will. Thank you, sir.
Okay, thank you. So anyone else who would like to share? So I guess that's about it from us. So so what happened is you'll be receiving an e-certificate. At the same time, we will also be providing you a link if you would like to register for the next session. Next session is going to be a lot more exciting, whereby it's very specific to online teaching strategies. So Dr. Dicky as well as Mariana, who is actually a very reputable science trainer, who will be exploring some of the online teaching strategies that you can adopt during this very challenging times. So yeah, so thank you everyone for being here. We thank you so much for your time. We hope you've had an enjoyable session. I had it. Thank you, Dr. Dicky. So I can find the link on the teacher's guide, Ms. Dina. Then just check it out. All right, okay. So yeah, thank you everyone. So I shall end the meeting. Dr. Dicky, do you have anything else to add before we end?
No, I think thank you again for attending. I know this is not the best time and after lunch, but thank you for also engaging in the Kahoot and everything. So I really appreciate your engagement. Thank you very much. Hope to see
Okay,
you next one.
yeah, thank you so much everyone. Thanks, bye.